completing the square. So the first thing I want to talk about is the perfect square trinomial. This is one of the factoring methods that we had. We didn't use it a ton, but this is where we actually get the quadratic formula. All right, and so the reason we're doing this is so that we can actually see where they come up with the quadratic formula. Typically, you're not going to use this as much. I'm showing this to you for my guys that will go on to calculus with me, because there will be times when you factor stuff out of a root by doing this method. And so this is a method that you need to know. But in this case, you're going to look and see, do I have a perfect square trinomial? By that, I mean, you're going to look at the first guy and you're going to say, is this a perfect square root? Yes, x squared does have a perfect square root. The perfect square root is x. You're going to look at the last one. Does 16 have a perfect square root? Yes, 16 has a perfect square root. That perfect square root is 4. All right? And then if I were to take these two, x times 4, 4x, and double it, 8x, do I get the middle one? Yes, I do, which means this is a perfect square trinomial. I'm going to use the sign here. If I were to do x minus 4 and square it, then I would get x squared minus 8x plus 16. All right? And I'm going to set that equal to the 49 over there. Now, here's the thing. Now that I've done that, I can actually solve it, because this is just like, we can look at it like, what if I had x squared equals 49? What would you do? You would take the square root of both sides, which is what you do here. On the left-hand side, just like over here, when you take the square root of a square, all you do is get rid of the square. So you have what is left inside, which is just x minus 4. On the other side, remember when you are doing the square root with a variable, you have to consider the positive and negative root. So the square root of 49 is 7, we know that, but we have to consider the positive and the negative 7, which means we have x minus 4 equals 7 and x minus 4 equals negative 7. This is where we're going to get our two answers. So we're going to add 4 to both sides. So x can equal 11 and x can equal negative 3. Those are my two answers. So if you have a perfect square trinomial, you can go straight to that square factoring and then take the square root of both sides and you're pretty much done. Just solve that little tiny binomial equals a number. All right? Completing the square means I actually don't have a perfect square. And so I need to consider, how would I make the perfect square? Well, I want to point something out. If I take the 8 and I cut it in half, what do I get? 4, right? And then if I square that, what do I get?
16.
Yes, that's how it will always work out. This middle guy cut in half, squared will be the third guy, okay? And that's going to be a perfect square trinomial. So when you don't have a perfect square, that's how you force one. So for example, if I had this guy equal to something and I wanted to use this method, I would cut the guy that's in front of my x in half. So what happens when I cut the 6 in half? I get a 3, right? So if I cut 6 in half, I get a 3. If I square that 3, I get a 9. That's what I would have to add to the end of that to make it a perfect square, so that I could factor it like this. All right? And so we're going to use that method to complete the square so that we can solve by completing the square. So to solve by completing the square, we have to create a perfect square trinomial. All right? And so right now I have an x squared plus a 10x over here, and I have a 15 over here. All I'm going to do is I am going to look at this term right here. 10. What happens if I cut 10 in half? What do I get? 5. And then I square it, I'm going to get 25. So I'm going to add 25 there and I have a perfect square. However, this is an equation. If I add 25 to the left side, in order to keep it an equation, what do I have to do to the right side? Right, so I'm going to do this. All right? And so now this side is a perfect square. All right? So I know it's going to factor to be whatever term this was, plus. So whatever this guy was when I cut him in half, that was 10. That's what's going to go here. All right? So I cut that middle guy in half. That's what's there. The other side is literally whatever I added. 15 and 25 gives me 40, right? And so this guy is going to be 40. And so now I can just solve by taking the square root, just like I did in the last section where we solved by taking the square root. Square root of both sides. Over here, you just get what's inside because you're taking the square root of a square. Over here, you do need to simplify, all right? So think about your factor tree, 2 and 20, 2 and 10, 2 and 5. Remember, if it pairs up, it can go out. If it does not pair up, it stays in, and whatever stays in together multiplies. So inside, I'm going to have a 10, 2 and 5, all right? Also remember that you always have that positive negative in front of it. Everybody see? When you take the square root, you have to do plus and minus in front of it, okay? What's my last step to get x by itself? Yeah, subtract 5. On the left-hand side, I have my x by itself. On the right-hand side, if you have a radical that stays a radical, so like square root of 40 doesn't have a perfect root. Had it been square root of, 36, I would actually solve it for the numbers, right? But I cannot combine negative 5 and the positive and negative root of 2 squared of 10. So I actually leave it just like that. That would be my answer. Negative 5 plus or minus the square root of 2 squared of 10. Now, here's the thing. If it wants it exact, that is the exact answer. If it says round to the nearest tenth, you put that guy in your calculator and you will have two answers. You would say negative 5 plus this in your calculator, negative 5 minus this in your calculator, okay? So if it wants it exact, then you're just going to leave it just like this. If it says round, you're going to have two answers. This technically is two answers, but you're going to have two different decimals that you would have from your calculator. So while these both had a positive 34, positive 15 in my root, it is possible to get one with a negative in the root, which we're going to do with quadratic formula. So if you were to do that, let's say this had been negative 15 when I took the root. Just simplify that with your I, right? Remember, if you have a negative in your root, you can take it out with an I. So even if, 15 is just 3 and 5, nothing comes out of it. But had it been negative 15, an I would have come out, and you would have had a positive. You don't want to ever leave a negative in your root, which we're going to do with the quadratic formulas. So you'll see that as well.